Okay, we're on page 35 now. I'm just going to skip the little note at the top. We'll go straight into the example, and I'll talk about the note later. So let's go through this question. We've got a line y equal mx plus b. We're not told what m and b are, but we are told it goes through the point -1, 0. It crosses the cubic y equal x cubed minus x at p, and two further points A and B with x coordinates alpha and beta respectively. Sketch the situation. Okay, so let's first work on the cubic first. So x cubed minus x. You can factor an x there, and then difference of two squares. So we've got x plus 1, x minus 1. Okay, so we've got a positive cubic, so it's going to start there, finish there. We've got x-intercepts of 0, -1 and 1. Y-intercept quickly. If you set x to be 0, convince yourself if you set x to be 0 here, the y-intercept is also 0. Okay, I think I've got enough to kind of sketch that guy, so I'm going to start. So 1, -1, 0. Okay, so I've got my three x-intercepts here, and it's a positive cubic, so it's going to look something like this, something like that. Okay, so that's y equal x cubed minus x, and the other thing I need to sketch in this graph is y equal mx plus b, and we're told it goes through the point P, which is at -1, 0. So -1, 0 is the point P, and I know that my straight line has to go through that point. What else are we told? Let's see if I can scroll. So the line crosses at P and two further points A and B with x coordinates alpha and beta respectively. It doesn't say which one's bigger, alpha or beta, so it doesn't really matter. So I can draw some consistency. Let's imagine the question said alpha is greater than beta. Now, convince yourself I have to be going through the point P, and I have to be a straight line, and I have to cross this cubic at two other points. So there's a lot of ways I could draw that line to cross through 2 points. Okay, so there's a lot of different ways I could go about it. I'm not sure. I've got no idea about the gradient. So we'll just draw it kind of like a general kind of line through P that'll at least I know will cross twice. Okay, this y equal mx plus b. It's a variable line because m and b can vary. Okay, the only thing that we know for sure is that we go through the point P. Okay, the way I've drawn it here, this must be my point A, which has an x value of alpha. This must be my point B here, which has an x value of beta. Okay, so that's my graph there. Just label my axes. Okay, so that's part A done. B, show that alpha and beta satisfy that cubic equation. Okay, remembering that alpha and beta are x coordinates of the points of intersection. We're looking for x values of point of intersection. So x values point of int, that means solve simultaneously. Okay, so I'm going to solve these two guys simultaneously. I'm going to let the right hand sides equal each other. Okay, so rearranging, I've got x cubed minus x minus mx minus b equals to 0. Then I can factor out a negative there. That'll be m plus 1x minus b equals to 0. Now, if you have a look, that's very similar. We've just got one little issue here. I've got a b here instead of an m. So maybe what we need to consider is back to this equation with m and b. It goes through the point -1, 0. So what does that mean? Well, if I sub in, I would get 0 equals to m times -1 plus b, and m equals to b from that. Okay, so if I call this star, I'm being a bit lazy with my working out. I probably should have rewritten that, but you get the idea. If I sub this into star, we get the required result. So I've got a cubic there, and alpha and beta will be possible solutions to this cubic. And also, there's a third point of intersection, -1. So the roots of this cubic will be the x values of the points of intersection here, which are -1, alpha, and beta. That I think will be useful for later on. Okay. C. Show that the midpoint of M of AB lies on the vertical line x equals to 1/2. So we can do something similar to we did in the previous page and consider the sum of the roots of this equation, which is minus b over a. Now careful, there's no x squared term here, so b is actually 0 here, so the sum of the roots is 0. So -1 plus alpha plus beta is equal to that, so alpha plus beta is equal to 1, and the x value of the midpoint will be the average of alpha and beta, which will be 1/2. So this is therefore the x value of the midpoint of AB is 1/2. And that's precisely what this question's saying. Show that the midpoint lies on the vertical line 1/2. Therefore, midpoint M of AB lies on x equal to 1/2. Okay, so that's part C done. All right. Lastly, find the line through P. So the line through P, that's why I call mx plus b there. That's this line here. Tangent to the cubic at a point distinct from P. Distinct means different. So we want a tangent line. So we want to go through P, and we want to touch somewhere else and be a tangent line. So if I can draw in red and try and show you what they're after. Just move this for a second. Let's go red. Yep. So we need to go through P, and we need to touch this guy and be a tangent somewhere else. So convince yourself that if you draw a line like this, that's a horrible line. I'll try and draw it a bit better. That line there is the line that goes through P, and it is a tangent at another distinct point. Okay, so that's the equation of the line. Okay, so that's what we're after for part D. Now the key thing to realize is that in order to get these 2 points of intersection have to start to come closer and closer together. You can imagine if I go so that I'm close but not quite there, my two roots are getting close. My alpha and beta are getting closer and closer together, And when it is a tangent, and this is the key thing, when we hit the tangent, alpha equals to beta. That's the key idea. So for D, when tangent alpha equals to beta, so therefore the roots become, we've still got -1, alpha and alpha. Okay, so we can work out what alpha is now by doing sum of roots again. So sum of the roots, it'll be -1 plus alpha equals to 0. That's sum of roots minus b over a. So that tells me that 2 alpha is equal to 1. Alpha is going to be equal to a half. So I've worked out that this value here must be a half. Okay. Alright, so now that we've worked out a half, we're going to need to work out that's the x value of this other point of intersection. We now need to work out the y value. I might work out the y value by noting that it's on the cubic. Okay, so let's sub in x equals half into cubic into y equal x cubed minus x. So it's going to be a half cubed minus a half. And if you do that, that's 1 on 8 minus a half. Which is -3 on 8. So therefore, we're after the equation of the line. The line goes through the point half -3 on 8. Now let's go back a second. So the line is y equal mx plus b, but we've also worked that to go through the point -1, 0, m has to equal to b. So the line is actually the form y equal mx plus m, because m is equal to b. So now I can sub in this point and work out what m needs to be, and then I've worked out my equation of the line. So -3 on 8 equals to m times a half plus m. Okay, that's going to be 3 on 2m's is -3 on 8. Let's times by 2. If I times by 2, that'll be -3/4 is equal to 3m, and divide by 3, m is going to be -1/4. So therefore the line will be y equals -1/4 x minus 1/4. So that line there, -1/4 x minus 1/4, will be the equation of this line here that is tangent, -1/4 x minus 1/4. Okay. That goes through P and is tangent elsewhere. Alright, let's see if we can see this visually quickly. Okay, I did a little demo. Alright, so here's the situation playing out, and what I've done is I've made it so that we can vary the gradient. And remember, the key gradient we're looking for is -1/4. And at -1/4, if I can get it to -1/4, there, spot on, -1/4. We can see that it's tangent when x is 0.5. Okay, nice. Another thing I did is the previous, a couple of parts ago, we saw that the midpoint always occurs at x equals 0.5. So let's vary a little bit, and you can see that midpoint moving on x equals 0.5. All right. So all the maths checks out. What I'd like you to do between now and next Wednesday, finish off all of polynomials. Pick and choose for Maths in Focus and Mastering Math. Pick and choose. Do all of Smarter Math. Make sure you get 10H done, and make sure you have 2.6 done as well. All right, I'll see that's what's going to be due for Wednesday. So all of polynomials, and remember you're picking and choosing for the Math in Focus and for the Mastering Math.